Okay, so as in the last video, we have discussed or we have calculated electric field intensity due to an isolated point charge. In today's video, we're gonna study the electric flux in very detail. What is that, and what's about its angles. All right. When the flux will be maximum, when it will be minimum, when it will be zero. We're gonna discuss everything in very detail. So let me tell you first what is electric flux. Before diving into that, let me write the topic here, that is electric flux. Electric flux. All right, so for suppose this is the circle I have, this is the circle. All right, I know this does not look like a circle, but it is a circle, and we know that the area of circle is scalar. All right, it is scalar because it has no any direction. All right, so I cannot say that is vector. However, area of a circle is scalar. But if I take a patch from it, for suppose I'm taking a small element or a patch from this circle, so that patch, patch, or this is small element of vector area, element of vector area, vector area. So this is vector, this is vector. Now why is this vector? The area which we're taking from the circle was the scalar, but if I am taking a small element from that, why is that vector? Why is that not scalar? Let me tell you now that. Wait. For suppose this I have a patch. All right, now I have taken this patch out. Now it will have a direction. Either I'll push it, all right, I'll put this in, or I'll take this out, which means I'll pull it. Either I'll pull it or I'll push it, which means either I'll put it inside or I'll pull it. All right, so this is a vector. Since it has a direction of pushing and pulling, so it is a vector. It is a vector. So now see what is electric flux. Now if I am taking this small element of vector area, for suppose this is Q naught, which is generating what? It is generating electric field. Electric field, we know that electric field is a region around the charge due to which it attracts or repels any other charge. All right, so this is electric field. This is electric field. But if I'm taking this small element of vector area and putting here, I'm putting that here. Alright, so I know the field lines or the electric field force lines will be passing through this vector area. Alright, so the electric flux is nothing but it is the total number of electric line of forces passing through this small element of vector area is what we call the electric flux. We know that when we will be putting this vector area inside the electric field, so electric field line will be passing through this small element of vector area. So the number of electric line of force passing through this small vector element will be known as electric flux. So now let me write the definition here. Electric flux. All right, the total number of electric line of forces passing through this small element of vector area is called electric flux. Is called electric flux. So why I am calling it a small element of vector area? Since I've already told you this is a vector. It will have direction, either the pushing direction or the pulling direction. But of course it will have direction. That's why I have called it as a small element of vector area. So the number of electric force line which will be passing through this small element of vector area is what we call the electric flux. Now let me tell you the nature of this electric flux. So nature of this electric flux. Alright, the first we're gonna discuss this quantity, what it is. Alright, then we're gonna discuss about the product. Then we're gonna discuss about its denotation, or it is denoted by what. So first is quantity. Alright, so we know that electric flux is a scalar quantity. It is a scalar quantity. I'll tell you why is this scalar quantity. I'll tell you. Second, it is the dot product. I'll tell you what is this dot product mean, but I'll tell you this. And it is denoted by a symbol called phi. It is phi. Alright, so now let me tell you why is this a scalar quantity and why we have a dot product. Right, so in other words, wait, these are very important MCQs. This chart is very important for the MCQ section. It is a scalar quantity, it is the dot product, and it is denoted by phi. Now in other words, which means the second definition of electric flux. The first definition of electric flux was the number of electric line of forces passing through a very small element of vector area is called electric flux. But now the second definition of electric flux is, it is the dot product. I'll tell you what is this dot product. It is the dot product. It is the dot product of electric field intensity, and small element of vector area. Alright, we have already discussed that when we are going to put this small element of vector area inside the electric field, the electric line of forces will be passing through the small element of vector area. So that would be known as electric flux. So in second definition, we are learning about the dot product. It is the dot product of electric field intensity, because we know that electric field lines will be passing through the small element of vector area. So it is the product of electric field intensity and the small element of vector area, because the electric line of forces will be passing through this small element of vector area. So it is the dot product. If I do write this in the mathematically form, how can I write this? We know that the electric flux is denoted by phi. It is denoted by phi is equal to, it is the dot product of electric field intensity. And we know that we have already discussed about electric field intensity. That was the vector quantity. Alright, so electric field intensity dot, it is the dot product, which means dot between the two quantities. It is the dot product of electric field intensity and the small element of vector area. Small, I can say it is del A area, and that is also a vector quantity. So this is a vector. Now this is the dot product. Wait, there is the dot product. Now we know that if we have a dot between the two vectors, if we are taking the dot product of the two vectors, the answer will always be scalar. The answer will always be scalar. Alright, when I'm going to remove this dot, what I'm going to get is phi is equal to electric field intensity into small element of vector area, that is also a vector. If I'm going to remove this dot, I'm going to have cos theta. And we know that when we have dot product of the two vector quantities, the answer will always be scalar. And when we have cross product of the two vector quantities, the answer will always be a vector. So here we have dot product of the two vector quantities. That's why the answer was scalar, which means electric flux is the scalar quantity. Electric flux is a scalar quantity. Now in the next video we're gonna drive its unit, what is the unit of electric flux, and we're gonna have its dimension as well, what is the dimension of electric flux. So this was all for today.